All right, hello everyone. In this video for chapter 5, we're going to learn how to name molecular compounds and then how to write their formulas. So, as far as molecular compounds go, remember that's 2 or more nonmetals. And these ones have prefixes. So, all the ionic compounds had no prefixes. We're still naming the first metal, or naming the first element, naming the second with the ending IDE, but we're adding these prefixes in. Okay, so here are our prefixes. I do need you to write them down, especially because a couple of them are different from math. Like tetra is 4, which is not what you're used to. And di is 2, that's also not exactly what you're used to. Okay, so make sure you have these prefixes down. Okay. If you need to pause, but I'm going to go ahead and move on. So, as far as the prefixes go, you will not put the prefix mono on the first element. Okay? So you will only use mono on the second element if need be. So, like we don't say monocarbon dioxide, we say carbon dioxide. However, we do use it on the second element if there's only one. So N2O will be dinitrogen monoxide. Okay, this one is very important. If your prefix ends with a vowel and your base starts with a vowel, the first vowel is sometimes dropped. Okay, except in iodide. Iodide is special. They do not get dropped on iodide. So really, we don't put 2 O's together and we don't put an O and an A together. That's the biggest thing. So, name these. So, A, we've got carbon. It's the first one. There's only one. Okay, we've got tetra is 4. And then chloride. Carbon tetrachloride. B, boron. Again, we've got that chloride. And 3 is tri. So, trichloride. C, sulfur. Hexafluoride. Okay, make sure you're paying attention to those subscripts, and there is no crossing. They go with the element they belong to, the one that it's directly after for molecular. Okay, N2O4 is dinitrogen. And then it's tetroxide. Okay, I'm not going to count it wrong for now, but just know Mastering Chemistry is probably going to be like, oh, you spelled it wrong. Make sure you double check. And they don't normally remove points then, but they are checking that. Okay. That's it for molecular. Now we're going to move on to acids. So acids are molecular compounds that form ions when they dissolve in water. Okay, and acids specifically are going to start with hydrogen. Then the second element will either be a polyatomic or be a nonmetal. Okay, there are 2 types of acids. There are binary, which have just 2 elements, a hydrogen and a nonmetal. Or there's oxyacids, which have a hydrogen and then a polyatomic. Okay, so we've got binary, 2 elements only. Oxyacids are going to have oxygen, which means the binary ones are not going to have oxygen. Okay, as far as binary acids go, they're composed of hydrogen and 1 other element. We will use the prefix hydro for binary. Also, this has no oxygen. Okay, we will use the base of the nonmetal with ic instead of ide, and then you put the word acid. There are 2 different words for these. Okay, so HCl is hydrochloric acid. HBr is hydrobromic acid. Okay, I do want you to note AQ means it dissolved in water. AQ means aqueous, dissolved in water. So that's it. As far as naming ones with subscripts, it's the exact same. So I do want you to know sulfur is a little special, and so is phosphorus. If y'all get those wrong, I'll try not to make you have to type them. But most of their word gets kept. or all of it. So like sulfur, this is hydrosulfuric acid because the whole word gets kept in sulfur. Oh, so there it is, hydrosulfuric acid. HF. So this is hydro. We know it's some kind of acid. And then the base of fluorine is fluor. And then you need to write ic. So that is hydrofluoric acid. Okay. Oxyacids, remember those come from those polyatomics that have oxygen in them. The number of hydrogens are going to depend on the oxy anion because its charges crisscross. Because remember, they become ions. So these numbers down here, you don't have to name that part. It comes from the charge of the anion. There are two types of oxyacids. Ones that end in ITE and ones that end in ATE. ITE goes to OUS. So you don't even put hydro. There's no hydro. You write the base with OUS and then acid. So one of my students several years ago came up with this. Sprite is delicious. Okay, because it's got the OUS and the ITE. 8 will go to IC, which is what all the other ones were going to. Okay. So all we're doing is taking the ITE or the ATE off and putting on the correct suffix. So nitrite as an acid becomes nitrous acid. Okay, again, those sulfurs, they keep their whole word even though it's just sulfite. Okay, so sulfite becomes sulfurous. Sulfate becomes sulfuric. Again, these subscripts are down there because the charge of the polyatomic came down. Again, though, notice they all start with H. That's what makes it an acid. Also, notice if oxygen is present, there is no hydro at all. Here is a huge flowchart meant to help you with naming. Okay. And here's just a process. You are going to have to go in and identify, is this ionic? Is this molecular? Is this an acid? And then if it's ionic, you need to say, is it type 1 or type 2? If it's an acid, is it binary or is it an oxyacid? And then you just need to go through the thought process and decide what is what. Okay. There's lots of acids that make up acid rain. So this is our relevance piece. As far as acid rain goes, most of it's going to be nitric acid and then sulfuric acid. And remember, those will dissolve nutrients in the soil, so that damages the trees. It'll damage buildings and materials. It'll pollute the water, so aquatic life dies. Okay, lots of different things. It's affecting the environment. All right, then that's it for this video, y'all.